June 10, 1944. The gray dawn breaks over the English Channel. On the cliffs near Le Havre, German officers raise their field glasses toward the horizon. What they see makes no sense. Out there, where yesterday there was only endless water, a strange skyline rises from the mist. Cranes, towers, floating roadways, and ships anchored in perfect formation. The sea itself seems to have turned into a harbor. Waves crash against steel walls that were never part of any map. Somewhere beyond, the muffled sound of engines hums beneath the wind, thousands of them, hauling supplies, trucks, tanks, and fuel barrels toward the Normandy beaches. One officer lowers his binoculars, pale and silent. The others stare, their minds unable to grasp what they are witnessing. It is not magic. It is not illusion. It is America's answer to the impossible. A man-made port, rising in the middle of the ocean, built faster than anyone believed possible. And it has already begun to change the war. By late 1943, the war in Europe had reached a moment of unbearable tension. Nazi Germany still held control of Western Europe, from the coasts of Norway down to the shores of France. Every Allied commander knew the same truth. Victory would only come when the armies of the United States and Britain could return to the European mainland. The question was, how? Across the cold, gray waters of the English Channel lay Hitler's Atlantic Wall, a vast network of concrete bunkers, steel obstacles, and artillery designed to make any invasion a massacre. The Allies needed not only to land, but to stay once they did. And to stay, they needed supplies, food, ammunition, fuel, trucks, tanks, millions of tons of them. That single problem haunted every planner in London and Washington. The last great amphibious landing, Gallipoli in 1915, had ended in disaster. To invade France meant supplying an entire army across open sea, without the safety of a captured port. Every port along the French coast, from Cherbourg to Calais, was heavily fortified, mined, and ready to be destroyed at the first sign of Allied assault. If the Germans could deny the Allies a port, the invasion would starve on the beaches. In meetings across 1943, Allied logistics experts wrestled with grim mathematics. A modern army consumed unimaginable quantities. One division alone could require 600 tons of supplies per day. Multiply that by dozens of divisions, and the numbers became staggering. Ships could bring men and equipment across, but without docks and cranes, unloading them fast enough was impossible. The Atlantic Wall didn't need to stop the landings. It only needed to delay the buildup long enough for German armor to counterattack. Churchill understood this danger better than anyone. He had learned it through failure, through Gallipoli's tragedy. When Allied planners discussed the upcoming invasion, codenamed Operation Overlord, he pushed an idea that sounded almost mad. If no port could be captured, then build one. Create a harbor from scratch, in the middle of the sea, and float it to the French coast. An entire artificial port, with breakwaters, docks, and roadways, assembled like giant Lego pieces, then towed across the channel and anchored offshore. It sounded like fantasy. Even some of his own officers doubted it could ever work. But America's industrial heart and Britain's engineering genius were about to make it real. By the autumn of 1943, Allied headquarters at Chef, the Supreme Headquarters Allied Expeditionary Force, quietly approved the plan. The name was simple but secret: Mulberry Harbors. There would be two. One for the Americans at Omaha Beach, one for the British at Gold Beach. The work began in total secrecy. Shipyards in England and Scotland filled with strange classified projects. Concrete caissons, some as tall as 5-story buildings, were cast in dry docks. Massive floating roadways, steel pontoons, and tugboats were prepared under codenames like Whales, Beetles, and Phoenixes. Workers didn't even know what they were building. Only a few officers knew the full design, and even they couldn't predict whether it would survive the channel's violent storms. Meanwhile, the Germans remained unaware. Their focus stayed on the French ports, expecting any Allied invasion to aim directly for a harbor. Their radar stations and reconnaissance flights saw ship activity across southern England, but misread its purpose. No one in Berlin imagined that the Allies were preparing to create their own harbors from the sea itself. The invasion's success would depend entirely on this invisible miracle of engineering. The Allies could assemble the largest amphibious armada in history, but without Mulberry, it would crumble under its own weight. Every jeep, every artillery gun, every ration box that crossed the beaches would rely on floating steel and concrete. And the world's most powerful industrial nations, Britain and the United States, were racing against time to make it happen before the invasion date set for June 1944. It was not just a battle of armies anymore. It was a battle of logistics, machines, and imagination. And behind every blueprint and weld, one impossible question echoed. Could human hands truly build a working port, not on land, but on the open sea? By the winter of 1943, the concept of the Mulberry Harbors had evolved from sketches into a colossal secret enterprise. Across Britain, coastal towns became workshops of invention. Engineers from both sides of the Atlantic gathered under military secrecy, testing models in wave tanks, debating steel tolerances, and studying tides. They were told little, only that what they were building would decide the fate of Europe. Winston Churchill himself had proposed the foundation years earlier. In a memo from May 1942, he had written, "Piers for use on beaches must float up and down with the tide. The anchor problem must be mastered. Let me have the best solution." His words lit the fuse. Soon, British engineer Alan Beckett designed the floating whale roadways, flexible steel bridges that could rise and fall with the waves, connecting ships to shore. Major Alan Cochrane and his team developed the Phoenix caissons, immense hollow concrete blocks that, once sunk, would form the breakwaters. Another group designed the bombardons, steel cruciform floats that could absorb and break the impact of waves. Meanwhile, in the United States, shipyards in Baltimore, Norfolk, and New York produced thousands of landing craft and modular pontoons. The U.S. Army Corps of Engineers coordinated with the Royal Navy, ensuring every component could be dismantled, transported, and reassembled like parts of a giant ocean puzzle. Each harbor, once completed, would stretch nearly 6 miles from the coast, complete with piers, roads, and artificial seawalls capable of withstanding 5,000 ships at once. The operation's secrecy bordered on obsession. Even senior commanders outside the Corps planning circle were kept uninformed. At Southampton, Portsmouth, and other southern ports, workers watched strange concrete shapes rise from the waterline, but were forbidden to ask questions. Locals guessed they were anti-submarine defenses or experimental docks. The press was silent. Even German spies reported nothing unusual. The name Mulberry was chosen precisely for its meaninglessness. It revealed nothing, yet carried a gentle cover that disguised one of the most ambitious engineering projects in human history. Each harbor was divided into coded parts: Phoenix for the concrete caissons, whales for the floating roadways, beetles for the supporting pontoons, spuds for the pier legs that adjusted to tides. Everything had to be ready in less than a year. Time was the greatest enemy. Every day of delay risked weather shifts, German counterintelligence, or leaks. The English Channel was notoriously violent, its storms able to tear apart ships in hours. Yet Churchill's directive was clear. The invasion of Normandy could not wait for good weather or perfect readiness. The harbors had to work the first time. In Washington, General Dwight D. Eisenhower, newly appointed Supreme Commander of Allied Forces, understood the stakes. His invasion plan, Operation Overlord, required landing more than 150,000 troops on the first day alone. To sustain them, he needed 10,000 tons of supplies every 24 hours. The numbers were merciless. Without a working port, his army would grind to a halt. He placed his trust in the engineers and in the American industrial system that could produce miracles on demand. Factories worked day and night. Hundreds of tugs and barges were requisitioned to tow the enormous structures. The Phoenix caissons, weighing up to 6,000 tons each, were constructed along Britain's coasts, from the Thames estuary to Scotland. When completed, they would be sunk to the seabed to form protective barriers. It was an achievement of scale no nation had attempted before. An artificial coastline built not in decades, but in months. By May 1944, as the Allied invasion fleet assembled in secret harbors under the code names Neptune and Overlord, the final pieces of the Mulberries waited quietly along the southern English coast. Thousands of soldiers, sailors, and engineers stood ready, knowing that when the invasion began, these massive concrete and steel sections would follow behind the first waves. Invisible to the enemy, until it was far too late to react. While the Germans reinforced Calais and Cherbourg, expecting the main invasion there, the Allies prepared to deliver their secret weapon on the beaches of Normandy. The men who built it called it the port that would follow the army. What they didn't know was that history would call it something far greater, the floating miracle of D-Day. And as dawn approached on June 6, 1944, that miracle was about to face its ultimate test. To understand the full scale of what the Allies built, one must first understand the technology itself. The Mulberry Harbor was not one invention. It was hundreds of them, fused together into a single living system. It was, in many ways, a floating city, designed to survive the fury of the sea and the weight of war. Each harbor was a masterpiece of modular design. The engineers divided the structures into components that could be built in secrecy at different sites, then assembled like a colossal jigsaw puzzle off the French coast. At the heart of it were the Phoenix caissons, enormous concrete blocks, some 60 meters long and weighing thousands of tons. These were built in dry docks across Britain, sealed with temporary doors, and floated out to sea when ready. Once towed to the Normandy coast, they were sunk in precise alignment to form a massive breakwater wall. Behind them, calmer waters would allow ships to unload safely, protected from the channel's waves. Then came the bombardons, steel cruciform floats anchored offshore to absorb and break the waves before they reached the Phoenix line. These acted as the harbor's first defense, a floating barrier stretching for miles. Next were the whales, flexible steel roadways connecting ships to the shore. Each section could flex with the sea's movement, allowing vehicles to drive directly from floating piers onto the beaches. Supported by floating pontoons called beetles, these roadways created continuous lines of transport that could carry trucks, tanks, and fuel straight to the front. No single nation could have built this alone. It was the union of American mass production and British ingenuity that made it possible. The British had designed the components. The Americans built them on an industrial scale. The result was staggering. More than 600,000 tons of concrete and 33,000 tons of steel formed the two harbors. To ensure secrecy, the Allies even created decoy operations to mislead German reconnaissance flights, scattering fake harbors and barges along the English coast. But technology alone did not make Mulberry work. It was the human determination behind it. The quiet courage of men and women who built something they could not even name. In towns like Southampton, Portsmouth, and Tilbury, civilian workers labored in freezing wind, welding through rain and fog, without knowing that their work would decide the fate of Normandy. They lived under blackout restrictions, aware that one German bomber could destroy months of progress. Yet morale remained high. They called the giant concrete forms beetles and phoenixes, almost affectionately, unaware that these strange shapes would soon become part of history. For the American engineers, the Mulberry represented a test of faith in industry itself. Many had been factory foremen or civil engineers before the war. Now they were designing roads and piers that would have to endure artillery fire and Atlantic storms. Some doubted the project's feasibility. Others believed it was the only chance of success. One U.S. officer remarked, "If we cannot land our supplies, we cannot fight. And if we cannot fight, we cannot win." What made the Mulberry remarkable wasn't just its size, but its adaptability. Every component had to be towable, reusable, and repairable under fire. When tested in the Solent waters before D-Day, the prototypes groaned, shifted, and cracked under wave pressure. But the design teams refused to give up. They strengthened welds, added reinforcements, and simplified the towing mechanisms. The pressure of time forged perfection through necessity. By May 1944, the full system had been tested in secret trials. Observers watched as convoys of tugs moved colossal caissons through narrow channels with almost impossible precision. When the final green light came, every tug, barge, and component was assigned a specific position in the invasion convoy. The operations coordination was breathtaking. Hundreds of vessels would move in perfect order, timed to the tides, synchronized by the meticulous planning of naval engineers and logisticians. It was a triumph not of battlefield glory, but of unseen genius. There were no medals for the workers who mixed the concrete or tightened the bolts in the night. Yet when the world watched the beaches of Normandy fill with ships, landing craft, and tanks, it was their work that made it possible. Every victory of 1944, Every town liberated, every bridge crossed, would trace its roots back to this silent triumph of logistics. And as the Allies prepared to launch Operation Overlord, they knew the success of the invasion depended not on courage alone, but on whether these floating harbors could truly survive the war. Its greatest test: the sea itself. The tactical importance of the Mulberry Harbors cannot be overstated. In the weeks leading up to D-Day, Allied planners understood that no matter how strong their initial assault was, it would mean little without a steady flow of reinforcements and supplies. In military terms, the Mulberries were not a luxury. They were survival. In Normandy, the beaches were shallow, with long tidal flats that made traditional unloading almost impossible. The German army, commanded by Field Marshal Erwin Rommel, had flooded the coast with obstacles: mines, steel hedgehogs, wooden stakes, all designed to rip apart landing craft and delay incoming waves. Rommel's belief was simple: destroy the first assault wave before it could build momentum, and the invasion would collapse. He had ordered that every harbor be fortified, every estuary mined. He expected the Allies to strike at Calais, where ports were strong and defenses dense. What he never anticipated was an invasion that would bring its own harbors along. From the tactical perspective, Mulberry solved the single greatest logistical puzzle in modern warfare: the rapid establishment of a sustainable beachhead. Each artificial port created a protected area for ships to unload, regardless of tides or weather. The harbor's floating piers allowed vehicles to roll straight onto the beaches without waiting for captured docks. This meant the Allies could maintain a continuous supply chain, even under fire. By the time German reinforcements began to react, the Allies would already have a small city operating on the sea, complete with repair stations, fuel lines, and anti-aircraft defenses. Eisenhower's staff called it the lifeline of Overlord. Without it, even the most brilliant battlefield strategy would have bled dry. The beaches themselves were never meant to support long-term operations. They were soft, uneven, and vulnerable to storms. But with Mulberry, they became gateways of industry: open, efficient, and self-sustaining. On the enemy side, the German intelligence apparatus completely missed what was coming. The Abwehr and Luftwaffe reconnaissance units were aware of shipbuilding activity across southern England, but none could interpret its meaning. Aerial photos showed mysterious concrete forms along the coast, but they were dismissed as anti-submarine barriers or coastal defenses. Even when the invasion began on June 6, 1944, the German High Command believed the landings were only preliminary, a feint before the real invasion at Calais. When reports arrived that the Allies were unloading tanks directly onto beaches without capturing a port, confusion spread through the German ranks. Officers suspected captured docks or secret French resistance infrastructure. None imagined an entire port system had been towed across the channel. German engineers, upon inspecting the remains later, described it as beyond comprehension. The technological audacity of the project defied their expectations of Allied capability. Leadership played a decisive role in bringing the vision to life. Eisenhower, though initially skeptical, recognized that war was no longer just a contest of armies. It was a contest of logistics. His deputy, General Omar Bradley, and Naval Commander Admiral Bertram Ramsay worked with extraordinary coordination to ensure that every piece of the harbor arrived at the right place and time. The British, under the direction of Churchill and his scientific advisors, maintained relentless pressure to meet deadlines. Churchill's leadership deserves special mention. His fascination with engineering and invention had often clashed with his generals in the past, but in the case of Mulberry, his instincts were prophetic. He personally reviewed design diagrams, pushed for trials, and argued for floating piers, even when skeptics insisted the seas would destroy them. He called it the port that would float with the tide of freedom. His persistence ensured the idea didn't die in committee, and history would vindicate him. For the Americans, leadership meant execution at industrial scale. They mobilized an army of builders, welders, and ship captains to make the impossible routine. Each floating segment was a small engineering marvel, but coordinating their assembly under war conditions required unprecedented logistical discipline. Commanders in both navies synchronized movements with tidal charts, weather forecasts, and convoy schedules. When all was said and done, the Mulberry Project stood as a monument to Allied cooperation. It was the combined strength of two nations, British innovation and American power, united by necessity. The US and Britain did not just plan a military operation. They redefined how war could be fought and won. Yet behind all its brilliance, the project carried risk. The English Channel was unpredictable. The success of the invasion would depend on weather as much as courage. Every commander knew that if the Mulberries failed, so would the supply lines. But they also knew that without them, there could be no hope of liberating Europe. And so, as the invasion began and the first convoys of ships crossed the Channel, thousands of men carried with them not only weapons, but the pieces of a floating miracle. They were heading toward Normandy, and the greatest logistical gamble in military history. June 6, 1944, D-Day. The largest amphibious invasion in human history begins under a gray sky and a rising wind. More than 5,000 ships fill the English Channel, stretching from horizon to horizon. Battleships thunder in the distance, their shells flashing against the French coast. Landing craft grind toward the beaches, carrying men who will remember the sound of that morning for the rest of their lives. Behind them, far beyond sight, lies the other half of Operation Overlord, not an army, but an idea. Within hours of the first landings at Omaha, Utah, Gold, Juneau, and Sword, Allied engineers begin their own assault. As soldiers fight for footholds on the sand, the massive task of building ports begins. Tugboats haul the first Phoenix caissons away from the English coast, each one a gray giant of hollow concrete. The channel is rough, but the schedule cannot wait. In coded messages, Allied headquarters orders the Mulberry convoys to proceed. Their mission: construct 2 fully functional harbors in less than 10 days, directly behind the invasion beaches. The journey is treacherous. Waves pound against the tugs, and some of the towering caissons list dangerously as they're towed through narrow lanes between minefields. One officer later described the sight as watching skyscrapers drift through a storm. But the convoys keep moving. By June 7th, the first Phoenixes reach the Normandy coast. At Omaha Beach, the Americans begin assembling Mulberry A. At Arromanches, the British begin Mulberry B. On shore, bulldozers roar through sand. Combat engineers mark positions while artillery still echoes in the distance. Each caisson is flooded to sink it into place, forming a wall against the waves. The harbor begins to take shape. First a line of concrete, then rows of pontoons, then the long steel wails stretching toward the beaches. It is construction under fire, a race against both enemy and sea. Allied air patrols keep German bombers away, but the weather is turning. The wind sharpens. The barometer falls. For a few days, the system works beautifully. By June 14th, ships are unloading supplies directly onto the floating piers. Trucks roll ashore, carrying ammunition, fuel, and food for the expanding front lines. American and British commanders breathe relief. The impossible seems to be working. Photographs taken from reconnaissance planes show the astonishing sight. A full harbor, complete with docks and roads, built entirely from floating steel and concrete. But the channel has its own plans. On June 19th, just as the Allies are pushing inland, the worst storm in 40 years sweeps over Normandy. It arrives without mercy. Gale-force winds, waves over 20 feet high, rain so heavy it blurs the horizon. For 3 days, the sea becomes a battlefield more violent than any artillery barrage. The Mulberry harbors, still young and incomplete, take the full force. At Omaha Beach, Mulberry A is struck hardest. The floating piers twist and buckle under the pounding surf. Caissons crack, tugs break their lines. Men fight to secure cables, shouting orders drowned by the wind. One officer later said it felt like trying to hold back the ocean with bare hands. When the storm finally passes, the damage is catastrophic. The American harbor lies in ruins. Nearly every pier and roadway has been destroyed. The remnants of Phoenix caissons litter the shore like wrecked battleships. For a moment, despair hangs over the Allied command. Without Mulberry A, the American forces risk supply collapse. Eisenhower IS staff faces grim calculations. How to feed and arm half their army with no functioning port. Some officers suggest retreating to the British harbor at Arromanches. Others propose shifting all operations to captured beaches. But the spirit of improvisation, the same that built Mulberry, refuses to die. Incredibly, within hours, U.S. engineers begin salvaging what remains. They recover intact sections of the floating roadways and redirect ships to offload directly onto the sand using WWIs, amphibious trucks that can drive through surf. For weeks, American logistics units work around the clock, proving that even without their harbor, they can still sustain the fight. It becomes a triumph of adaptation, a symbol of Allied resilience. But at Arromanches, the story is different. Mulberry B, though battered, survives. The British harbor weathers the storm, its breakwaters holding firm against the chaos. Engineers repair damaged sections, reinforce anchor points, and within days, ships are unloading again. The Allied beachhead still has a lifeline, one floating city that refuses to sink. And as the waves settle, the Germans begin to realize what has happened. From observation posts along the coast, they can see it now. An entire port where no port should exist. When the war ended in Europe, the scale of what the Allies had achieved through Mulberry Harbors began to truly sink in. A post-war report by the British Ministry of Supply noted that over 2.5 million men, 500,000 vehicles, and 4 million tons of supplies had passed through the artificial ports. Without them, the Allied invasion might have stalled for months, allowing Germany to regroup, fortify, or even counterattack across the Seine. In an age before modern container cranes and reinforced logistics hubs, this was nothing short of engineering wizardry under fire. American generals like Eisenhower later admitted that Mulberry was one of the few technological efforts that directly shortened the war. What radar did for air defense, Mulberry did for logistics. It gave the Allies a constant artery of movement, pumping men and materiel into the European front faster than any Axis power could comprehend. The Germans, for their part, were stunned. In captured intelligence documents found after the war, Wehrmacht officers described their disbelief that floating docks could stand the fury of the Channel. One field report from Normandy in late June 1944 even noted, "The enemy constructs new harbor facilities faster than we can destroy them." To men who had relied on static fortifications and fixed ports, the concept of mobile artificial harbors seemed like something out of science fiction. They were trained to destroy bridges, ports, and rail lines, not to fight against a port that simply sailed in behind the invasion fleet and assembled itself from steel and concrete like a mechanical city. When German officers were interrogated after the war, many openly admitted that they had underestimated Allied industrial and engineering capability. General Gunther Blumentritt, who had helped plan the Atlantic Wall's defensive strategy, reportedly said that the sheer audacity of building an entire harbor at sea was beyond our imagination. The failure to predict this innovation was not merely a tactical oversight. It was a symptom of a deeper flaw within the German command. The belief that engineering genius alone was not enough to overcome geography. For the Americans, geography was just another obstacle to engineer through. In the years that followed, remnants of Mulberry were studied by nations across the world. The idea of modular, prefabricated ports inspired future military logistics, from the Korean War to modern humanitarian operations. Even NASA engineers, decades later, studied Mulberry's design principles when developing modular docking systems for space missions. What had begun as a desperate wartime solution became a foundation for global engineering philosophy. Build fast, build flexible, build anywhere. Meanwhile, along the beaches of Normandy, fragments of the great floating harbor still rest beneath the waves. Concrete caissons, rusted and encrusted with barnacles, remain visible at low tide. They are silent now, but their presence speaks volumes, of men who worked under blackout conditions, welding steel while bombs fell, and of sailors who navigated convoys through U-boat-infested waters to deliver pieces of an impossible harbor. For the local French villages, those structures are more than relics. They are memorials to collaboration and courage, a reminder that innovation and sacrifice walked hand in hand. The U.S. Army Corps of Engineers preserved Mulberry's blueprints, using them as a reference for decades. Their success reshaped American military doctrine, reinforcing the principle that logistics win wars as much as soldiers do. From the Red Ball Express to later Cold War infrastructure, the idea of mobile supply lines and temporary operational bases traced its lineage back to those storm-lashed harbors off the Normandy coast. In the end, the Mulberry Harbors were never meant to last forever. They were designed to stand for just a few months, long enough to serve their purpose. yet their legacy endured far beyond the steel and concrete that formed them. For the German officers who once watched in disbelief from coastal bunkers, the sight of an entire port materializing from the sea was not just a tactical shock. It was the moment they realized that industrial might, when paired with imagination, could turn the tide of a world war. Their reports concluded with one phrase that historians still find haunting in its simplicity. They brought their own world to our shores. And from that moment, the myth of German invincibility began to sink beneath the waves, replaced by the cold, undeniable truth that America and her allies could build victory itself, one floating pier at a time. The war had changed. The world had changed. And it was the ingenuity of engineers and builders, not just generals and soldiers, that carried the Allies toward final victory. In the stillness after the storm, when the guns of Normandy had long fallen silent, a quiet truth remained etched across the sea. That victory in modern war was not only won by courage on the battlefield, but by brilliance behind the lines. The Mulberry Harbors stood as monuments to that truth. They were not grand fortresses or mighty battleships, but floating testaments to the minds that dared to reshape nature itself for a cause greater than survival. They showed that the power to change history lies as much in blueprints as in bravery. What set America apart in that moment was not merely its industrial output, but its philosophy. That no problem was unsolvable if enough ingenuity, cooperation, and grit were applied. The German command had planned for soldiers, tanks, and ships, but not for an entire port built in the middle of the ocean. They had fortified the beaches, yet never imagined that the enemy would simply bring their own harbors to bypass the barriers of geography. In that gap between imagination and reality, Germany's strategic confidence began to unravel. Even now, decades later, the remnants of Mulberry's concrete caissons scattered along the French coast serve as silent reminders of that audacity. They whisper stories of men who refused to accept the impossible. Engineers, divers, sailors, and laborers who built in secret and assembled under fire. They remind us that in war, the greatest victories often begin not on the front line, but in the quiet resolve of those who build the means to win. For historians, Mulberry remains one of the finest examples of what happens when necessity meets invention. For soldiers, it is a symbol of trust, that behind every fighting man stands an army of unseen builders ensuring the way forward. And for humanity, it is a lesson that progress, no matter how desperate its origin, can light the path for generations to come. Because long after the war ended, long after the last wave touched the remnants of Arromanches, one truth endured: that when nations unite vision with will, even the ocean itself can be conquered one floating bridge at a time.